Hello everyone, my name is Stoica, and together with my colleague Wolfgang we are going to present you a little bit of history and also future about mobility. And this is why our article is named Move Like a Bosch. A short presentation, myself, Stoica, with 14 years of experience in the automotive industry. I started from developer level, low level, and up to head of department in charge of prototyping new technologies now. And with the help of our colleagues from hardware, mechanical, software, everything is combined now. So we are going to show you in the article how this is going to look like in the future and what the future basically is going to show us.
Thanks. So welcome also from my side. Presenting mechanical engineering in for a software magazine is maybe a bit strange, but I think there are some connections. And also when you're looking back on that experience that I had in Bosch, there are some software aspects, some data management tools, and a lot of knowledge graph. Bringing the bridge to mechanics. I think everybody immediately thinks about cars, mechanics, oily fingers, and so on. So what belongs to that? But of course, cars also changed, and I just put there the top left a modern vehicle from 1896, a French company. They brought this on the road. I think when I look on it with the responsibility for steering parts, with the responsibility for parts, to make that happen, I can imagine something, but it does not really have something to do with my job. And if you look on a modern car today, I mean, I just put a picture there. You can look outside, you see them around. They are looking completely different. Similar, it's maybe also on the computer side, if you're looking on this. So Bosch in 1967 came up with the Jetronic. So this was the first time that electronic in principle entered the car in the way really to fulfill the emission standards to ensure that the combustion engine worked sufficiently good. And then in 1975 we already see the first computer in the way digital. You can program it, maybe not too many registers, but at least something to program. But how this developed, and then in the bottom right you see something like a vehicle computer of today. A thing that my colleagues here developed together. You see it's completely different. When you're looking on this, you can imagine now out of a sudden you have plenty of more interfaces. You have high-speed connectors to the different cameras, you have Ethernet connectors, you have the requirement that software can process all this. This of course calls for compute power. You immediately think in compute power how to dissipate the heat. So it comes to that you really can only do this, that all these pieces, software, hardware and mechanic, are working together. But of course this is also only a piece, and the things develop further. And what you see in my back are in principle the levels of automated driving. So from the left to the right you see a little bit of support by computers to drivers, and on the right you see in principle completely taken over by computer, that you have full driving automation. To get this a little bit touchable, that you have an idea what are these different things. So level 1 is something like adaptive cruise control. So you keep the distance to the driver in advance, you can easily follow him. On level 2, your car is automatically parking in your garage. Bosch is providing this. You just have to check on your phone that you stop in the case of emergency, that you don't hit something, which works. Level 3 is the highway pilot. On the highway, in the defined domain, the car is automated driving, but you still, as a human, have to pay attention that if something is happening, if something in the domain is changing unexpectedly, you can intervene. And then if you go for level 4 and level 5, you have in principle automated driving. In level 4, a reduced domain. You see this already when you see valet parking, so when you just put your car in front of the garage, and the car is fully entering and finding its parking spot, is parking there without any contribution from your side. And level 5, I mean, we dream about it, we work on it, but unfortunately you cannot see it on the road yet. But maybe soon. If you think on all this, it's pretty clear that the different domains have to come together, but that innovation that all is driving this is even bringing us to more steps further. So we don't have just to change the architecture in the way of what you think in software. We also had, of course, to change the architecture of the complete setup, how it works together. Here, I hand over to you again.
Thank you. And just imagine on the left side, because we are speaking about software, we have few line of codes because we are just helping the passenger with some additional sensors, warnings. Imagine how you go from level 1 to level 3, you have more and more software that needs to be introduced into the electronic control unit. And if we want to go to level 4 and to level 5, where basically the steering wheel is optional and can basically not exist there in the car, you need to have a lot of software and complex software. And this, with the current architecture that we have in the cars right now, it will be a complete mess. Because we have so many electronic control units, so many computers talking to each other, and it's really, really hard to master all this complexity. So what we are working on is changing the architecture to a more structured architecture where we replace and we have vehicle computers, like we call them. And these vehicle computers are able to process multiple cameras, radars, lidars, and take one decision that will enable the car to go alone without the human intervention. And this is something that we here in ECC, we are working on both hardware, mechanical, and also software, because it takes a lot of implication. And one of the products that we are really proud and working now developing is the ADAS integration platform, where you can see on the left side, we have multiple solutions with multiple mechanical housings, which can support air cooling, active air cooling, water cooling even, in a car. And why do we need this? We need this because if we have a lot of processing power in a computer to process all the images, all the radar data, all the LiDAR data, we are going to have power dissipation, heat. And we need a way of cooling this. And basically this is what our colleagues from mechanical and hardware are helping us make the software run, because if the ECU and the CPU heats up, it will stop. So the software cannot run without the mechanical and the software. And to conclude, here in ECC we are working on all levels, mechanical, hardware and software, to bring this new future to life, because this is not the past, this is not the present. What we are working here in ECC is the future, and we are trying to bring the future into the road. And this is also the motto that we have: let's move like a Bosch. Let's bring the future today on the road. Thank you.
Thanks a lot.
Thank you. If you have any questions, when do you think we'll get to, I don't know, level 5?
So at the moment we have level 3 available in Germany, which is approved. Mercedes has, I don't know if we have an EQS here in Bosch, which can run automatically on the highway alone. It can switch lanes, it can stop, it can signal, it can go out of the highway alone. But it's only on the domain controlled on the highway. In order to get to level 4, we need this complexity to solve. So we are working together to this. But this is a really, really tough question, because Tesla is working on this. We are working on this. A lot of car manufacturers are working on this. But the cost at the moment is too expensive to be able to put in a production car to have this.
And maybe to add something to your statement, I think we are all engineers, therefore we are focusing on the technical part, but it's especially also a society and legal topic, because we really have to get to this point that we accept cars which are fully autonomous driving. And also this is of course a journey which, yeah, we will see how long it takes.
Yeah, to complete a little more, who's going to pay for the damage? Who's going to be insured in level 4 and level 5 when you have no steering wheel, you have no pedals? Basically, who owns the car? Who's responsible for the car? The OEM, the driver, the software? So this legality is still in work, and this is basically the major step that we need to take as a society to have level 4 and level 5 on the road.
Might be easier to just go to the flying cars and that's it.
No, that's also regulated because you have a lot of flying planes and everybody's going to go crazy. We are going to be like flies everywhere.
Okay. Okay, thank you very much.
Thank you.
We still have a question? Okay.
Yeah, I was going to ask, how difficult is to test, for example, for the level 3, how is the testing process for reaching out to level 3?
On software or on mechanical side?
On both.
And on system, yeah.
At the system level. Also, very simple said, the ECUs are running several test iterations. So we are doing environmental testing for the ECUs to really ensure that they can sustain the lifetime. This is of course taking several hours, temperature cycle, high temperature, under load, without load, passive, active. Big program.
Yes, and imagine you have not only one version of hardware with software. During the development phase, you have 5, 6, even 7 hardware samples, hardware variants that are going to be tested along 1, 2, 3 years, where the software is tested, it's improved, the hardware is also improved, so it can be legally brought into the market. So you have mechanical test, then you have acceptance test by the NCAP authorities. Also you have in the same time software testing, because you are testing functionality here in the building, just developing it. Then you are going to test the entire system on a racetrack, on an airstrip, for example, where we do also our test with our colleagues from video and from radar. And this is a multi-cycle testing topic.
Okay. Okay, thank you very much.
Thank you.